This is the senior design project of the Mechatronic Enhancements to a Robotic Foot Structure and was completed by a team made up of Zach Bolter, Braden Love, Zach McKenzie, and Alex Steiger. This project was sponsored by Dr. Stephen King of the Kingetics and mentored by Dr. Chad Ulven. Dr. King has developed a composite foot orthotic that is claimed to improve the efficiency of the gait cycle. This orthotic works by harnessing the kinetic energy of the system and converting it into potential energy, then releasing that energy back into the system, producing a higher cycle efficiency than the standard athletic foam-soled shoe. The gait cycle is defined as the movements that the foot and ankle are subjected to during a normal walking stride. The purpose of this project was to create a testing device that simulates this gait cycle in order to quantify the efficiency of the orthotic compared to a market shoe. The results of the test would then reveal whether or not the orthotic performed as expected by improving the performance of the gait cycle. During this first semester of work, several designs for the testing apparatus were proposed and analyzed, and a final design was selected. The testing device would need to mimic heel strike angles of 15 to 30 degrees and represent the impact forces of a 200-pound person. The final design was a multi-component system that represents the gait cycle by sliding a weighted sled that is drawn up using a winch to its release point for testing. A slide rail is used to vary the angle of impact, reaching both the maximum and minimum heel strike angles as constrained by the design. Once the sled was released, the heel comes into contact with the ground and then rolls forward, transferring the harnessed impact energy into usable kinetic energy as it reaches the toe-off stage of the gait cycle. The counterweight of the apparatus helps shift the center of gravity forward so the foot structure completes the cycle. The foot apparatus ends in the catch mechanism and can then be winched back into its starting position. A compression load cell was later implemented into the foot structure to measure the impact loads induced onto the foot structure. The materials for this project were sourced from both local and online suppliers and was manufactured at NDSU with the assistance of the NDSU shop mechanic, Mr. Shannon Feastons. The material was cut and welded before being ground smooth for painting. Paint was later applied and the winch was mounted for the final assembly. Testing was completed in the NDSU biomechanics lab to utilize their force plate. Tests were conducted with both a foam-soled shoe and the Kingetics orthotic at heel strike angles of 15, 23, and 30 degrees. A force versus time graph was plotted for the resultant normal force of the force plate for both the orthotic and the athletic shoe. The data showed that the testing apparatus oscillated throughout the stride, indicating bouncing. The initial heel impact forces for the athletic shoe and orthotic showed no significant difference. However, the orthotic had a higher oscillation frequency and damped the motion better. In conclusion, the project was successful in delivering a repeatable testing apparatus that was able to achieve quantifiable results over a wide range of testing parameters. The testing results showed that the kinetic orthotic performs differently than a foam-soled shoe. This project will be able to assist Kingetics in further product development by quantifying the effect of the orthotic.